All right, AP Physics. This is the answers video for day 9. We went over this pretty extensively in class, but here's the final answers video. So Sophia is pushing a 6 Newton with a 6 Newton force to the right. Man pushing with 2 Newtons of force to the left. What is the net force? So again, anytime you draw a diagram, you should do it with a straight edge, but I'm going to try to get through this. One thing I want to emphasize is the length of the vectors. 6 Newton vector, whatever length you show it, should be 3 times as long as the 2 Newton vector. So the net force is, if they're opposing, is 6 minus 2, 4 newtons, and you must either draw an arrow or say to the right. You don't have to do both. And that would be that, okay? Explain how friction force allows you to walk. Okay, so I'm going to say this. I want you to write it, put it in your own words. Okay, so as your foot pushes on the ground, there is a friction force. A friction force is a force between two objects, a force of resistance between two objects touching each other. So as your foot touches the ground, there's a resistance, and as your foot pushes backward, but based on your muscles, your leg muscles push your foot backward, it sticks to the ground. It can't move. Therefore, there's an equal and opposite, a reactive force from Newton's third law that pushes your body forward, that propels your body forward. So generally we speak of friction as being a force that opposes motion, but in this case, it opposes the motion of your foot, but creates a reactive motion of your body moving forward. What is gravity? It is an attractive force between two objects with mass. Now, technically, I mentioned in one of the classes that one of the objects doesn't have to have mass, but in this class we're going to use Newton's definition, which says that both objects have to have mass, and that's the way the AP exam treats it as well. So, attractive force between two objects with mass. What name is given to the attractive force of gravity? And you could say gravitational attraction, but the more common word is weight. W-E-I-G-H-T, weight. Why is this force different on the moon than on Earth? Because the moon has less mass. Okay, and it's a function of mass based on Newton's gravitational equation. Okay, so if one of these masses is your body and the other one is the planet, if this planet is the moon, it's smaller than if it's the Earth. The mass of the moon is smaller than the Earth, so the force of gravity would be smaller on the moon. Okay, if two objects are 4 meters apart and then move to become 1 meter apart, how does the gravitational force increase? How much does the gravitational force? So this is what's called a relative relationship. It doesn't tell you an exact gravitational force in newtons. It just tells you what the relationship between them is. Okay, my way of saying it is the original position, x0, over the final position, xf, is going to equal, the original position was 4 meters, and you have to square that based on this right here, d squared, over the new position, which is 1 squared, 1 meter, right here. That's going to equal 16 over 1 is 16. So 16 times. So if the gravitational force is 10 newtons when they're 4 meters apart, it would become 10 times 16, or 160 newtons when they're 1 meter apart. So it just tells you what the relationship is between the forces. Another way to do it is a factor of change. You take this equation and you set everything equal to 1. Okay, and everything is 1. If you take all these are 1s, then the force becomes 1. Now what you're going to do is say the distance is 4. So now we're going to keep the masses at 1 and the g at 1. Again, we're just making up simple numbers, and we're going to make this 4 squared. And that would equal 1/16. Okay, so at the further distance, the 4 meter distance, the gravitational strength is going to be 1/16 of this right here. So that gives you the same answer. Okay, what is momentum? Momentum is mass times velocity. And it's instantaneous, not average. That's why I like to put the I like that, even though most books do not. Force equals mass times acceleration, just to compare the two, because they can be easily confused. So if an object is moving at a constant velocity, it can have momentum, but it doesn't have any force to it, okay? State the law of conservation of momentum. Again, I'm going to say it, you write it. Is the sum of the momentums of objects that collide before they collide is equal to the sum of the momentum of those same objects after they collide. So each one separately might have a different momentum that it had before they collided, but if you take the sum of all of them, let's just assume it's two of them, the sum of the two of them before they collide, and then the sum of the two of them after they collide, that will be the same. And a very important point, that's true of any collision. It doesn't matter what kind of collision it is. Okay, explain the difference between elastic and inelastic collision. So an elastic collision, generally you can think of it as bowling balls. Two bowling balls just clicking together, but that is really not the way you tell it, okay? Because bowling balls may not be elastic, but you can generally think that's the nature of an elastic collision. Inelastic is two lumps of wet clay. Two lumps of wet clay. Okay? Now, I'm going to say this and not write it, so you write it. Okay, momentum is conserved in all collisions, elastic or inelastic. We just said that up above. However, energy is conserved only in elastic collisions. So you would need to calculate the energy before and after of all the objects, and if they do not equal, then it is not an elastic collision. If they equal each other before and after the energies, then that will be an elastic collision. Okay, here we go. Here the force is shown being applied. What is the acceleration of the box? So you've got it, first two steps to this. You've got to get the net force, which is 18 minus 6, because they're opposing each other, equals 12 newtons. Then you use F equals ma. It's asking you for acceleration. So if we broke this down, we would have written these out as separate numbers, but I'm kind of doing this quickly for you here. So if you solve that for A, you end up with A equals F over M. So A is going to equal 12 newtons over 4 kilograms. And that equals 3 meters per second squared. And again, acceleration is a vector, so you have to state which direction. It's in the direction of the bigger force, so it's going to be to the right. Okay, so that answered this down here. If the mass of the box was increased, how would it affect the acceleration? So you can just generally take this formula, A equals F over M. This is really the most useful way to write F equals ma. Because it says this, that if you increase this force, increase the numerator, just mathematically you're going to increase this number over here. So if you increase the force on a particular mass, it's going to increase the acceleration. It's going to accelerate quicker. Okay. If the 18 Newton force was increased, how would this affect the box? So if this became, let's just say 30. 30 minus 6 would be 24, and 24 divided by 4 would be 6 meters per second squared instead of 3. So it would have increased. So 18 Newton force was increased. How would it affect the acceleration? The acceleration would increase. If the 6 Newton force was increased, how would this affect the acceleration? So now the opposing force is going to get greater. It depends how much it increased. If it increased to be bigger than 18, then it would actually start accelerating in the other direction. But let's just say it goes to 12. So 18 minus 12 is 6, and 6 divided by 4 would be 1.5. So the acceleration would decrease if you increase the opposing force. If you increase this all the way up to 30, then 30 minus 18, it would now be going to the left. So 30 minus 18 is 12. 12 divided by 4 is 3. But it would be 3 to the left, not to the right in that case. Okay, so write that out. Okay, don't just write down an answer. Okay. What is a friction force? So a friction force is a force that opposes motion. Okay, so it's a force that opposes motion. Generally speaking, it slows things down. Okay, how does a friction force cause you to move forward when you walk? So we gave that answer earlier. I do want you to write it again. It is not a mistake that it's asked twice. Once the pre-assignment, when you're watching the video, the second time is the actual body of the assignment. So do write that answer out twice, and it's on the front page, the second question down. Okay, gravity. Define gravity. It's an attractive force between two objects with mass, two or more objects with mass. Does gravity pull objects of different weights to Earth at the same acceleration? We're going to answer that in class today, so I don't want to answer it right now. What is acceleration? It's any change in velocity. So it's change in velocity over change in time. That would be the formula to actually get the numeric value or the magnitude of the acceleration. But it's any change in velocity. It could be speeding up, slowing down, or turning a corner, going in a changing direction, in other words. And we'll deal with that type of acceleration at a later time. Okay, why do some objects fall slower than others? We're going to talk about that in class. What two factors affect the force of gravity? So it's the mass of the objects. Greater mass will be greater gravity, and the distance between them. Greater distance will be less gravity. Okay, you feel the Earth pulling you down. You feel the gravity of the Earth. But if you were 1 billion miles away from the Earth out in space, you would not feel the gravity of the Earth because of the greater distance. What name is given to the force of gravity? That's weight. So I'd like a complete sense answer. Weight, because that's how you remember the answer rather than just a one-word answer. So weight is the name given to the force of gravity. Okay. Is your weight on Earth different than on the moon? And we answered that one already. Is your mass on Earth different than on the moon? Okay, so weight on Earth, we said, is different because the mass of the Earth and the mass of the moon are different. And using Newton's formula, you'd get a different numeric value. It would be less on the moon. Your mass is the same. Mass is defined as the amount of matter in your body. And basically, think of it as how many atoms and molecules you have making up your body. And that doesn't change anywhere in the universe. Now, on Earth, they basically have a constant relationship. I'll just say it. You can write it down if you want. There are 2.2 pounds for every kilogram of mass. So 2.2 pounds of weight for every kilogram of mass. But that would change if you were on the moon. All right, so a 50-kilogram boy and a 60-kilogram girl stand 2 meters apart. And there you have G. It's 6.67 times 10 to the negative 11. So this is Newton's gravitational formula. So break this out, okay? So it says, what is the attractive force? So you want to know force. And you can put a G there for gravitational, which you're trying to find. Write down the numbers using problem-solving format. Okay, so you lay it out like that, and now the formula is this. Plug in numbers. Okay, and that would give you an answer right around 5,000. 5,002 is what I have. and it's a force, so it's in newtons. Okay, and that's what you would get times 10 to the minus 11th. You got to watch out for that because you have this 10 to the minus 11th there. So it's a very small force. Another 5,000 newtons would be a measurable force. So I'm going to write it down here. Okay, and we're going to talk about adjusting the decimal at a later time, but that's the way you could write the answer, and that is, again, is in newtons. Okay, if you double the distance between the objects, what is the strength of the attractive force at the new distance? Okay, so this is, if you double the distance, then that would change the distance from 2 to 4. So now you'd have the formula would be okay, and that would equal 1,250 times 10 to the minus 11. And again, we'll deal with adjusting the decimal at a later time. So this is 1/4 as much as this number right here. Okay, and if the distance is 1/4 the original distance, I'm just going to set up the formula in this one. Okay, the original distance was 2 meters. We're going to do 1/4 of that, so that's going to be 0.5. If you divide 2 by 4, or multiply it by 1/4, you're going to get 0.5. Okay, so I'll set it up for you, and you can do the calculation on that. All right, a ping pong ball of 0.2 kilograms, 0.002 kilograms is rolling at 1 centimeter per hour. A bowling ball of 4 kilograms is stationary. Which has the greater mass? Well, clearly the bowling ball does, 4 kilograms, okay, much greater than 0.2 kilograms. Which has the greater inertia? The bowling ball does, because inertia is a function exclusively of mass. You don't put a number to inertia, but the greater the mass, the greater the inertia. It's how hard is that bowling ball to get rolling, or once it's rolling, how hard is it to get it to stop rolling? That's inertia, and that's a function of mass. So the bowling ball has the greater inertia, which has the greater momentum. Well, even though it's very small and light, the fact that the ping pong ball is actually rolling, so because momentum, is mass times velocity, and the ping pong ball has a velocity. The bowling ball does not have a velocity. It's stationary. So the answer would be to this would be the ping pong ball, because it is moving. The bowling ball is not moving and therefore has no momentum. Okay, a 10 kilogram ball is rolling with a velocity of 3 meters per second. What is the ball's momentum? So I'm kind of shortcutting it. I would like you to use problem-solving format. You want to get used to that for the exam, writing things down in a very orderly fashion. So the mass is 10 kilograms, and the velocity is 3 meters per second. So that's going to equal 30 kilogram meters per second. What is the ball's force? So there's no acceleration on the ball. It's moving at this constant velocity. So no acceleration means no force. Okay, so F equals 0 newtons. As long as it's just rolling along at a constant velocity, it has no force. Okay. When would the ball exert a force? When it struck something, when it struck another object. Now, you could push on it to make it go faster, but we're talking about if it's rolling, it doesn't have a force until it bangs into something. And then there's a deceleration. It slows down. That changes the velocity, and that's when you would have a force. Okay? All right. This is 25. Okay, so a car has a momentum of 500 kilogram meters per second. How long would it take for the car to stop if 100 newtons of force was applied? So this is the momentum impulse. Momentum is mv. and impulse is Ft, and they're equal to each other. So when I did the soccer ball example, okay, the soccer ball was coming at me with a certain momentum. So I could either apply a small number for this and a long number for this, so small force for a long amount of time to get that number, whatever mv multiplies to, or the same number mv, the same momentum, I could apply a much larger force for a very short amount of time. Okay, so that would be the case where I just batted the ball down, if you remember that example in class. Okay, all right, so but here they give you the momentum. You don't have to do mv, so it's going to be 500. The force they give you is 100 times t. Okay, and just dividing both sides by 100, you get t equals 5 seconds. Now I'm setting a bad example for you, just scribbling these out, but I want you to write them out properly, okay? Get in that habit. Okay, if you want to catch a ball, should you apply a lot of force for a short time or a small amount of force for a longer time? And the answer is you want to catch it. You want it to kind of stick to your hand, stay in your hands. So a small amount of force so it doesn't bounce off, but then you're going to have to do it over a longer amount of time. Okay, so that would be to catch the ball. What is an elastic collision? Okay, elastic collision is a collision where the two objects strike each other and immediately bounce off. And you can think of bowling balls, although we said bowling balls are not always elastic collisions, and we'll deal with that concept later on. But generally just think of bowling balls clicking together and bouncing off. What is an inelastic collision? It's a collision where the two objects stick together in some way. And think of two lumps of clay, wet clay, hitting each other. They're going to just stick. So that's an inelastic collision. In what types of collisions is momentum conserved? Both types, elastic and inelastic. In what types of collisions is energy conserved? Only inelastic. In fact, that's how you determine if it's elastic. You have to calculate the energy before and after the collision. You can't just say, hey, they're bowling balls, so that's elastic. You can't do that. You have to actually calculate the energy before and after and determine if they're equal. And if they're equal before and after the collision, then it is an elastic collision. Okay, so we're going to have a conservation momentum problem here. And what we're going to do, first of all, correct this. This should be after. This is a before and after picture. In fact, you can even draw a line down the middle like this. This is the two bowling balls before they collide. This is the two bowling balls after they collide. What you're trying to figure out is the velocity and direction of the 4-kilogram ball after the collision. Okay, so the mnemonic to remember this is you're going to multiply these two numbers together and these two numbers together. Then when you get down here with those products, you're going to add them together, those two, and then they're going to come to this, and then this has to equal, this box has to equal that box. That's the conservation of momentum. The before momentum has to equal the after momentum. Okay, so we just do that quickly. Now, this is moving to the left. Again, you have to assign a positive direction. Generally, we say it's to the right. This one's to the left, but it doesn't always have to be that way. Okay, so that means it's going to be a -8. Okay, 2 times 4, but it's in the negative direction. So that's going to give you this. That's got to equal this. Okay, and so 2 times 6 is 12. Again, I'll put my signs here. So you multiply these to get 12. So this plus this has to equal 16, so this must equal 4. Okay, so something times 4 equals 4, so this must be 1 meter per second. And since it's a positive 1, it's got to be moving in the positive direction to the right. Logically, you would know that anyway. The bowling ball can't suddenly move through the other bowling ball. Okay, here we go. Again, so this one is Okay, be sure you understand those numbers. If you don't, come talk to me. Right. And a couple more conservation momentum problems. Okay, so you have two skaters facing each other. This one's 50. And we're going to say she's the 20. Okay. And so when they're just standing there, they have no momentum. Again, the only formula you need is P equals mv. P equals mv. Well, you might need the impulse, but we don't need that for this problem. Okay, so they have no velocity right now. So his momentum is 0, her momentum is 0. You add those together, the total momentum of the two of them is 0. They have no momentum. Now they push off, and it says he's going to move at a velocity of 4 meters per second. So that's going to be mass times velocity. That means his momentum is going to be 200, 4 times 50. But again, we're going to call the right the positive direction and the left the negative direction. So he's moving in the negative direction, negative 200. Okay. Now she is 20 kilograms, and we want to know what her velocity is. Okay. So this times this, these two added together have to equal 0. So I'll bring this 0 over here. These two added together have to equal 0. So we'll just set up an equation. Do it right here. Okay, and remember this is a negative over here. He's going in the negative direction. So it's negative 200 positive 20V, add 200 to both sides, 20V equals 200, divide both sides by 20, and you have V equals 10 meters per second. That's her velocity, okay? So she's moving 10 meters per second to the right. That's your answer. Okay, this is the tricky one, but I think everybody knows it now. So he throws a ball this way. It's 2 kilograms times 10 meters per second, so it has a momentum of 20 meters per second in the positive direction. That's the key. Now it bounces back. It's still 2 kilograms. It's moving back though at 8 meters per second, but the 8 is in the negative direction. Okay. So that's going to equal negative 16. Negative 16. So this is the tricky part. It's moving 20 to the right, coming back negative 16. So draw a number line. And here's 0. And here's negative 16. And over here is 20, positive 20. So what's the difference between these two numbers? How much did this change? A change means a difference, which means a subtraction. So if you can just count if you want, it's going to be 36. To go from negative 16 to 20 is 36. But mathematically, you take the 20, you subtract negative 16, not 16, and you get positive 36. Okay, kilogram meters per second. All right, and that would be the answer for this. Okay, so keep that one in mind. They could hit you with that one on the test, because many students miss it. Okay, that takes care of this answer key.